All right, today we're diving into a really incredible area of medicine, immunotherapy. And look, we're not talking about just carpet bombing our immune system anymore. This is about building a highly specialized toolkit, one that's designed to precisely tune our body's own defenses.
And that really gets to the heart of the problem, right? For years, the main strategy was just broad suppression. And it worked, kind of, but it often came with some major costs. So the real question modern medicine is asking is, how can we be more like a surgeon with a scalpel, and less like, a sledgehammer, just knocking everything down? Let's find out. Okay, so here's how we're going to break it down. We'll start with why we even need these drugs in the first place. Then, we'll explore two major strategies, blocking signals and controlling cell movement. And finally, we'll wrap it all up with the big picture trade-off that all this precision gives us.
So first up, what's the actual problem we're trying to solve? Well, in conditions like rheumatoid arthritis or inflammatory bowel disease, your immune system kind of gets its wires crossed. It starts seeing your own body as the enemy and launches this massive, full-scale attack, which leads to all that chronic inflammation and damage. Okay, so how do we actually step in and fix this? The first big idea is to block the key messenger molecules that are coordinating that friendly fire. But before we get into the cool, new, super-targeted drugs, we got to get a handle on the risks of the older, broader drugs they were built to improve upon. So this right here, this is our starting point. These broader therapies, yeah, they can work, but they kind of put a damper on the entire immune system. That can open the door to serious infections. And they carry other risks too, sometimes affecting the heart or in really rare cases, the nervous system. And that is the exact problem scientists were trying to solve by getting way more specific. Okay, let's get into our first set of precision tools. Meet the interleukins. Just think of these as little text messages flying around between your immune cells, shouting things like, "attack here," or "we need more troops over here." These next drugs work by basically intercepting those very specific messages.
So, our first target is the interleukin-6 pathway. Drugs like tocilizumab are great for things like rheumatoid arthritis. But look, this is important. Precision doesn't mean zero risk. You can see right there, there's a really specific warning for something serious called GI perforation. That's a tear in your gut, especially for people with a history of diverticulitis. It just shows that a specific target can have a very specific risk.
And this is such a perfect example of why this stuff gets tricky in the real world. Doctors use a marker called C-reactive protein, or CRP, to see if there's inflammation or an infection. But these drugs can actually push that number down, masking a real problem. It just goes to show you how doctors have to totally change how they think when using these new targeted therapies.
All right, next up, the IL-17 pathway. These drugs are absolute powerhouses for skin conditions like psoriasis. But, and here it is again, that precision trade-off. It seems like the same pathway that drives all that inflammation in the skin might actually be protective in the gut. So, while they're fantastic for the skin, you got to be careful because they can sometimes make inflammatory bowel disease worse. It's a super targeted tool for a very specific job.
So you can see how this idea is starting to build, right? Here we've got drugs that hit the IL-12 and 23 pathways. They're useful for both psoriasis and IBD. And check out that note for ustekinumab. The infection risk is generally lower than with those broader drugs we started with. I mean, that is a huge win for precision therapy. And believe it or not, the toolkit gets even more specialized. We've got other drugs that target the very specific pathways that drive allergies. For instance, some are built just for eczema and asthma, while others go after the unique things that cause severe allergic asthma. It's just an amazing example of matching the perfect tool to the exact type of inflammation you're dealing with. Okay, let's totally switch gears for a second. We've been talking about blocking messages, but what if we could just stop the immune cells from ever getting to the party? Like putting up a roadblock so they can't even get to the site of the inflammation. And that's exactly where a drug like vedolizumab comes into play. It targets this very specific protein that acts like a GPS signal telling immune cells, hey, go into the gut. By blocking that signal, this drug is basically the bouncer for your gut, preventing those inflammatory cells from ever getting inside. And this brings us to this really cool concept, gut selectivity. The drug's action is pretty much confined to the gut. It isn't messing with the immune system all over your body, just in the one place where it's causing trouble. This is an absolute game changer. So the big takeaway is right here on the screen. Because the drug is working locally, the risk of body-wide systemic infections is often way lower than with those broader drugs we talked about at the beginning. This is it. This is the whole point of targeted therapy. Hit them hard where you need to and leave everything else alone.
All right, so let's zoom out and put all of this together. We've seen how modern immunotherapy gives doctors this incredible toolkit to fight autoimmune disease with just incredible precision. It really is the difference between a sledgehammer and a scalpel. Instead of weakening the whole immune system and just hoping for the best, these therapies target a single molecule, a specific cell, a precise pathway. Now, the side effects don't just vanish, but they become different. They're more predictable, and a lot of times, way more manageable.
And that leaves us with this final thought. We're moving away from these one-size-fits-all treatments and into an era where we can pick the exact right tool for a patient's specific disease. It really makes you wonder, what's next? Just how precise can we get?